This is a question posted on College Board for practice for AP exam. The apparatus shown consists of two identical springs of neglectable mass, each with spring constant K is equal to 20.4 Newton per meter, and each attached at one end to a vertical rotating pole. Identical small spheres of mass M are attached to other ends of the spring. The spheres are constrained to horizontal motion by horizontal guides of neglectable friction, each of which has a ruler below it for measuring the radial position R of the sphere. The system can be manually rotated about the pole's axis. In the lab experiment, a student adjusts the rotational speed so that the spheres move to a desired radius R. For each such value of R, the student measures the rotational period T. The student's partially completed data table is shown below or on the side. The length of each unstretched spring is given L 0.15 meters. So calculate the missing values from the table shown on the right. Show your work in the space provided. So we're just gonna have space that I'm gonna have for you here. So the data that is given, you have K, you have the radius that is changing depending on the speed, and we have a mass. Here it is. We have a mass that is given, and the length of each unstretched spring. So when it stretches, it has a different length. And in the table, I see the information that is provided. The radial position, so that would be this position, the radius. They give you this is R. The period to make one rotation, acceleration, spring force changing because X is changing R. R would be your X. So let's look how we would calculate these. So for this line, for the third line, we're missing the spring force and we're missing centripetal acceleration. So centripetal acceleration is equal to V squared over R. V, I'm going to write it right here for now. V is equal to 2 pi R over the time it takes to make one revolution. So if I square this, I have to square that. That will give me 4 pi squared, radius squared, and R is given, so there's R, divided by T squared and R, and T is also given. So now if I plug in the numbers, I have 4 pi squared, radius squared is 0.24 squared, divided by the time is 0.53 squared, and I could cancel one of the radiuses, so I didn't have to. So this is the same radius. I could write just this, not to be confusing. So this is also radius, and I did not have to do this one squared, and one of the radius would be cancelled. So my final answer is, if I calculate that, I should get 33.7 meters per second squared. So this is going to be 33.7. And to find the force acting on the mass by the force of the spring, we have the formula. I don't have to write my kx negative because negative doesn't matter, so I'm going to take the absolute value, so that's going to give you the magnitude of the force. And k is given, k is 20.4, so I have 20.4, and the stretch of the spring is I have to, so this is relaxed spring, and this one in the table is the one that when it is stretched. So this would be the normal size of the spring. This is the new size of the spring. So that's the change of the size. So 0.24 minus 0.15. And that will give me 1.84 newtons. So I can fill this up and say 1.24 newtons, and it's measured in newtons. For B part, they say on the axis provided, plot the data points for the spring force F spring as a function of the acceleration. This is centripetal acceleration. Label the axis, including the scale. Draw a straight line that best represents the data. So this is very common for AP exam when they don't give you the axis or what the axis are. They just give you the graph and say find the equation that you could use to plot, and then they will ask you probably below in C or D, they will ask you what the slope of this graph means. So in this case, we have the y-axis is F of the spring, and your x-axis is centripetal acceleration. Measures in meters per second squared, and spring is force of the spring measured in newtons. So now I have to look at my acceleration points and force of the spring and plot them. So I'm gonna look, the spring goes by, the acceleration goes 10, 20, 30, 40, 50, 60. So I'm gonna go 10, 20, 30, 40, 50, and 60. And my spring goes by, smallest is 0.61, and then 0.6 bigger, and then this was, I believe, 124, correct? 184. Yes, this point was 184. So this is 184. When we did calculations, I probably entered wrong number. So we have 184, so 0.6 more, and then another 0.6 more. So I'm going to make 0.5s. So this is 0.5, 1, 1.5, 2, and goes up to 3, 2.5, and 3. And for my points, I have, so when at 11.2, I have 0.6, so it's somewhere here. At 25, I have 122, so somewhere here. At 33, I have 184. At 33, I have 184, somewhere right here. And then at 47, I have 245, so it will be somewhere here. And then at 61, I have 306, so 61, I have 3.6, somewhere here. So it looks like the line is gonna look something like this. So for C, they ask you to calculate your slope. So the slope the slope is rise over the run, and from my graph I see that your rise is, I'm gonna choose different color, green. So your rise starts at 0.61 and ends at so your rise would be this part, and so goes from 0.61 to 306, so that is 306 minus 0.61, that's that length. And for your x-axis, the run is this part, so it goes from 11.2 to 61.2, so that is 50. So the slope is equal to 0.05 kilogram. How do I know it's going to be kilogram? This is what they ask me. What does the slope mean? I know that F net is equal to mass times acceleration. So this is your y. Then you have mx plus b. And in this case, your slope is your mass. In math, this m represents slope. That m represents slope. And in our case, this m represents mass. So that's how I knew this will be in kilogram. And what does it mean, that mass? This is the mass of the spheres that you have on the sides. So the slope that we just found, it's the mass of each of the spheres. And then for D part, they say one sphere and one spring are removed from the rotation apparatus. They are hanging vertically so that the sphere is now suspended from the spring as shown. So the image that they show you. Describe a procedure you could use and the measurements you would make to verify the value obtained in part C using the setup shown in the picture. Show how you would use the measurements described in part D, the first part, to verify the value obtained in part C. So because the spring constant is given, you have the force acting on the mass is F of the spring, and you have mg, and this is the mass that we found in part C1. So this is right here where they mention it, obtained in part C. So when the spring stretches, I would have F of the spring is equal to mg. Describe the procedure you could use in measurements you would take. So the measurements you would have to take in this case, you would have to measure by how much the spring would stretch from its equilibrium position, the one that they gave you earlier, from its equilibrium, L is equal to 0.15. So by how much it would stretch, because F of the spring is equal to Kx, and then you have mg. So if you calculated the mass correctly, and K is given 20.4 all the way at the beginning, K is equal to 20.4 Newton per meter. So K is given, then Ux should be calculation wide, showing you exactly the same number as it stretches. So you would need to have a ruler and measure that X, and if they match, then you can say, okay, I found this mass correctly in part C. And that's it for this question. So again, this is what College Board posts for you for review before the AP exam.